My name is Michael Bryan II,
And the next slide,
this
as you'll
is
see,
calculus
5 over
1000,
4 for our limit.
and this is challenge
Like I
2016.
said previously, because
So
sine
the first problem we have
4
today is from chapter 2,
x
section 4,
times 5 over 4 gives
problem
you
number
sine
36.
5x.
Limit of x
We then
to
have
0. What
sine
is
over 5x
sine?
over sine of 5x.
What is the limit
with
of
5
sine
over
5x over sine
outside
5x when a
parentheses.
approaches 0?
And since sine of 5x over
So
sine of
if
5x
we look at this
equal to
problem,
1,
we can see that
limit at x approaches
sine
0
of
is equal
5x
to 5
over
sine
sine
of
of
4x is comparatively close to sine of 5x
our
over
next
sine
problem
of
comes
5x,
from
section
which
6
of
to
chapter
1.
2,
So now we
problem
plan
number
to
28,
solve for the limit at x approaches
how
infinity.
now we want to find how to make sine of 5x
2 plus square root of
over
x
sine of
over
4x
2 minus square root
equal
of x.
sine 5x over sine 5x.
So in order to solve this problem, we're going to multiply by the inverse identity of the top function, equivalent of the top of the function. So we multiply 2 plus square root of x over 2 minus square root of x times 2 minus square root of x, because as you can see,
over 2 minus square root
in order
of
to make the 4 turn into a 5, we have to multiply it by 4
then
over
leaves
5,
us with
5
4
over
minus
4,
x over 4 plus x,
which will make 20 over
both
4,
the x
which will
4's
also
cancel out,
equal to 5,
which equals the
of
negative
x plus.
Now we
Over
multiply
x,
both the top and bottom
which
by
equals negative
5
1,
over 4, so the
which
limit
gives us
x approaches infinity at
and
2
the
plus
next
square root
slide,
of
as you'll
x
see,
over
5
2
over
minus
4
square root
for
of
our
x is
limit.
equal to negative 1.
Like I said previously,
Our last problem is
because
finding the
sine
derivative of
4
x when f of x is equal to square root of
times
x
5
and
over
x
4
equals
gives you
1.
sine of 5.
So since they were finding the
We
derivative
then
of
have
f of
sine of 5x over sine of 5x.
we're going to use
the
the derivative limit equation, which is
and
here,
since sine of 5x
where
over sine
limit
of 5x
as h
equal to 1,
approaches 0 is equal to
limit at x approaches 0
f
is equal
of
to
1
5
plus
over
h,
4, or f of a plus
Our
h
next problem
with any
comes
given
from
variable minus
section
f of
6
1
of
or
chapter
f
2,
of a over h.
problem number 28.
The limit at x approaches
This then
infinity
gives us
square root of 1 plus h
square
minus
root
square root
of
of
x
1 over 2
over
minus
h,
square root of x.
and we're going to multiply it by the identity again and give us,
In order to solve this problem, we're
root of 1
going
plus
to multiply by the
plus square root of 1
inverse
over
identity of the
square root
top
of 1 plus h plus
of the
square
top
root
of the
1.
function. So we
This is
multiply
then
2 plus
equivalent to
square
1
root of
plus
x
h
over
minus
2
1
minus square root of
over
x
h
times
2
2
minus
minus
square
square
root
root
of
of
x
x plus square root of
over
1,
2 minus square root
which
of
is equal
x.
to h over h times
This then leaves
square
us
root of
with
1 plus
4
h
minus x over
plus
4 plus x.
square root of 1.
Both the x 4's
This gives us
cancel out,
1 over square
which
root of 1
equals
plus
the
h
negative x
plus
plus
square root of 1
1,
over
which is
x,
equivalent to, as
which
h
equals
approaches
negative
0, 1
So
over
the
the limit
square root of 1
x
plus
approaches
square root of
infinity
1,
as equal to
2 plus square root of x
1
over 2
over
minus
square root of
x
2,
is equal to negative 1,
which is our limit.
Our last problem is finding the derivative of x when f of x is equal to square root of x and x equals 1. So since they were finding the derivative of f of 1, and we're going to use the derivative limit equation, which is here, where limit as h approaches 0 is equal to f of 1 plus h, or f of a plus h with any given variable minus f of 1 or f of a over h. This then gives us square root of 1 plus h minus square root of 1 over h, and we're going to multiply it by the identity again and give us times square root of 1 plus h plus square root of 1 over square root of 1 plus h plus square root of 1. This is then equivalent to 1 plus h minus 1 over h times square root of 1 plus h plus square root of 1, which is equal to h over h times square root of 1 plus h plus square root of 1. This gives us 1 over square root of 1 plus h plus square root of 1, which is equivalent to, as h approaches 0, 1 over the square root of 1 plus square root of 1, which is equal to 1 over square root of 2, which is our limit.